Good morning, friends. Let's continue our discussion about accumulators. So, as we have learned that Spark natively supports accumulators of numeric types, for example, long or double, which will look very quickly. And programmers can also add support for new types. For anything which we create our custom objects, so for that also, there is a way that we can create our custom accumulators. So let's continue our discussion about numeric accumulators first. So we can create a numeric accumulator by calling this SparkContext.longAccumulator for long and DoubleAccumulator for double. And we can accumulate values on that. So whenever any task is running on executor nodes in the cluster, so we can call this add method to accumulate it. As you have also learned that all the operations which are only associative and commutative, only those can be done on an accumulator. So also we learned in the previous video that only addition and multiplications are associative and commutative. It means that only those operations can be used on an accumulator. And so we can use the add method on the executor nodes, but for reading the value, it can be only done on the driver program by calling its value method. So this is our base accumulator v2 class, which is defined in the Scala API. And here we can see that this is an abstract class which has got in, which can accumulate the inputs of type in and produce output of type out. So out can be it's a type that can be read atomically and should be thread safe. So let's start like basic with long accumulator and double accumulator first. So we have got this long and double accumulator here. So this is long accumulator, an accumulator for computing sum, count, and average of 64-bit integers. 64-bit integers, but in Java it's only 32-bit integers. 64-bit integers means the long. Okay, so in Java, so these are the methods which are provided to us in the API. For example, we can have add and average and all, and also we can create the name and reset the value. And this is the main thing, sum, which we be using. So I already have got a custom unit test case available where we will go through all this, play around with this long accumulator. So in this unit test class, first of all, I created a SparkConf object by calling this new SparkConf and setting the app name as this test class name and setting the master as local star, which means that all the 4 cores that I have that would be used as nodes here in my local mode. Now let's go back to our long accumulator in SparkDD unit test case, where we'll see all those long accumulator API methods. So first of all, because it's just have this try with the resources, so I will create a Java Spark context based on the SparkConf. And once I get the Spark context, this is how we can create a long accumulator by calling SparkContext.SC.longAccumulator. And this is the custom name that I have given to my accumulator. So my long accumulator as given here, this is the name of this variable accumulator that I have created here. So as we can see that the next one assertion is that because we have already assigned the name, so it should be giving me the name as non-empty, which is the first API method which I am going to test. And also when I call name.get, then I will get the exact name that I have created when I doing the registration. It actually is exactly same as what it is defined in the long accumulator API in this name. It returns the name of this accumulator and can be only called after registration. Okay, so this is where we are registering it, and this is where we assert that it's not empty, and this is the value of this name of this accumulator. And after that, let's create our data. This is a list of data which is containing all the long from 1 to 5. That's why it's like 1, L2, and all. And let's create the RDD as we have learned previously, that how to create an RDD by calling SparkContext.parallelize method on this list. Once we get this list and once we get this RDD, then this here for RDD, we are trying to accumulate for all these values and add it to our accumulator. So this is where I'm using this lambda expression and our method reference here by for each. So my accumulator would be having the sum of all this data which is there in my RDD, which is the sum of first 1 to 5 long values. So this is again, if you go back here, This is for the add method that we have, add speed to the accumulator. This is what I'm calling. Okay, so once we add it, so of course, I mean, we can further check that it's not 0 because the sum of the first 5 values would be 15. This is what we are asserting here. That assert equals the accumulator sum would be 15, average would be 3 because 3 is the middle of it, and the count is 5. So we have got 5 elements in our accumulator. So these are the various API methods. You can go through the API again. I'm just using everything that, for example, average is here, count is here, and is 0 is here, sum is here. So I'm just trying to like use all these API methods available in this long accumulator. Okay, so once we test all this, that about the sum, average, and count, as we have mentioned that we can only like read the value. Also, I mean, of course, we can do the add on the RDD, which is distributed across all the executed nodes, but the value can be read only at the driver program side. So this is what I'm asserting here, that only the driver program can read the accumulator's value using its value method. So what I'm doing is that accumulator is at driver side. This is another method available that it's only available at driver side to be read driver program. And that's where we actually reading this value. When we call this accumulator value, this is where I'm asserting it that it should be 15. So this is what I was talking about, that when we call about value, this is only to be read at the driver side. If I'm trying to like execute it at a particular node in the cluster, then it will not work. And finally, I test another method like accumulator.reset. Reset will actually set it as 0. And this we can assert it by just checking this as assert true that it should be 0. So let's revise it again. What we are doing is that we are setting the name first. We are creating our long accumulator variable. We are setting the name and asserting it. And after that, we create a list of first 5 long variables and then store it and then create the RDD, my local RDD with calling this parallelize method on this list. After that, I accumulate by calling this add on all these 5 long values. After that, we do all those type of assertion that it should not be 0, and we asserted the sum, average, and count. And after that, we asserted that the value that can be read only at the driver side by using this is at driver side. And then we reset this accumulator, which will set the value of this accumulator to 0. So now let's run this and confirm that all these assertions are correct as per our understanding. Just click on this run button. So as seen that it's fine. There's no the test has passed. So it means that whatever assertion that we have put here, this is all correct. Okay, so this was all about long accumulator. Now, if we just continue our discussion about the primitive types again, I mean using long, exactly same we have got for double accumulator. So double accumulator is nothing. The only difference between long accumulator and double accumulator is that we are just using double values here. So I've created a exactly similar test case. So I'll not go through like line by line again. It's exactly same as what you've done. The only difference is that in the data that I'm going to use here is a sort of like double value by using 1D. In the previous one, I was using 1L for creating the long values here. This is the only difference. And once we actually do all the remaining assertions and the methods that I'm testing is exactly the same. So again, for the double accumulator, if I run it, it should be giving me the same, the test should pass as it passed for the long accumulator. Okay, as seen that even the double accumulator is exactly same and the test has passed. So this was all about primitive types for long accumulator and double accumulator. In the next video, we will talk about more complex type where we'll create our custom type of object and use it as an accumulator. So see you all in the next video.